Hello students, so the next group of instructions that I am going to discuss under 8086 microprocessor instruction set are shift and rotate. So first let's talk about the shift instructions. So the first instruction that I am going to tell you about under shift instruction group is SAL or SHL instruction. So the format for writing this instruction is SAL or SHL. Any mnemonics you can use. You can use SAL or you can use SHL. Both means the same thing. Both will work in the same way. So the format for writing the instruction is you can write SAL or SHL whatever, and along with that you need to write destination and count. So how it works? So let's take an example. So whatever destination you're going to write, you will be writing 8-bit register. It performs the shifting of 8-bit. It performs shifting of the bits in the 8-bit register. So how it performs the shifting? SAL or SHL are two mnemonics used for the same instruction. This instruction shifts each bit in the specified destination. So whatever destination you are using, it will shift each bit in the specified destination towards the left, and 0 is stored at the LSB. So as the bits are getting shifted towards the left, obviously the LSB bit will go to B1. So 0 we need to insert, or this instruction will insert 0 to the LSB. And the MSB is shifted to the carry flag. This MSB will get shifted to the carry flag. Now this destination can be a word or a byte. It can be a byte or word. It can be in a register or in a memory location. Obviously the destination can be a register, or a memory location can also be specified in the instruction, and it can be a byte or a word shifting also. So the number of shifts are indicated by this count. But if the number of count shift is required is 1, we can place 1 in the count position. If the number of shifts are greater than 1, the shift count must be loaded in CL register, and CL must be placed in the count position of the instruction. For example, if the number of shifts or if the number of counts that are required, as I have told you here also, the number of shifts are indicated by the count, and if the number of shifts required is 1, so we can place the 1 in the count position. As you can see, the format for writing is SAL or SHL destination comma count. So in the count we can write the 1 if the number of shifts required is 1. But if the number of shifts required is more than 1, like here I need 5 shifting. So what I will do, first I will need to store 5 in the CL register, and first I need to store 5 in the CL register, and then I'll write CL in the place of the content. So how I will be writing SAL, and AX is the register where whose bits I'm going to shift using this instruction, and CL will tell about the counts. That is, I need 5 counts, so 5 times of shifting. So I'll mention here CL, and CL will be loaded with 5. So again I am repeating, what does this instruction do? It will shift the content of the destination towards the left. The LSB will get loaded with 0, and the MSB will get stored in the carry flag. Now the next instruction under shift operation is SHR instruction. So this instruction shifts each bit. Again, the format for writing this instruction is SHR destination count, and this instruction shifts each bit in the specified destination, whatever destination is mentioned, whether it is a register or a memory location. What it will do, this instruction with the content of the specified destination towards the right, and 0 is stored in the MSB, and the LSB is shifted to this carry flag. So destination can be a byte or a word. It can be in a register or memory location, and the number of shifts are indicated by this count. So if the number of shifts required is 1, so we can directly mention 1 here, as you can see here, SHR CX 1 means the number of, what this instruction will do, it will shift the content of CX register towards the right by 1 count. Only one time of shifting will occur. And if I need more than one times shifting, what I will do, I will mention that count and store that count in CL register, and I will mention the CL register in place of count. For example, SHR AX comma CL. So what is happening, the number of shifts are indicated by count, and if the number of shifts required is 1, we can place 1 in the count position. But if the number of shifts are greater than 1, then shift count must be loaded in the CL register and CL must be placed in the count position. Flags affected, obviously all flags will get affected. Now the next instruction is SAR instruction. In SAR instruction, this is the arithmetic right shift. These were logical right shift. SHR is logical right shift and SAR instruction is arithmetic right shift. So what happens in SAR instruction, what it does, whatever the format for writing this instruction is same, SAR destination count. So destination can be a memory location or the register mention, and what it will do, this instruction will shift the content of the destination towards the right. The LSB will get stored in the carry flag, and the MSB in HR, what was happening, 0 was getting stored in the MSB, but in SCR instruction what will happen, the same MSB will get copied and get stored in the MSB only. The MSB will remain same. So what it does, this instruction shifts each bit in the specified destination some number of positions to the right, and as a bit is shifted out of the MSB position, a copy of the old MSB will be put in the MSB position. The LSB will be shifted into the carry flag, and in case of multiple shifts, what will happen? In case of one shift, we will mention the count 1 in place of count, and if the count shift, if the shifts that is required is more than 1, what we will do, we'll store that count in the CL register, and we will mention CL register in the instruction, that is SAR DXCL. So you can write any register here. You have to mention that register for which you want the shift operation. Like if you want the shift operation for the content of DX register, so you will mention DX register. So SAR, again, it is performing shifting operation towards the right, and the LSB will get stored in the carry flag, and the MSB will get stored in the MSB only. So in this way the whole shifting operation will occur. Now the next group is rotate group. So under rotate group we have this instructions RCL, ROL, RCR, ROR. So RCL is rotate left throw carry, ROL is rotate left, RCR is rotate right throw carry, and ROR is rotate right. So ROL instruction, what this instruction does, this instruction rotates all bits. First of all, let me tell you what is the format for writing this instruction. So the format is ROL destination count. So this instruction will rotate all bits in a specified byte or word of the destination to the left some number of bit positions. So MSB is placed as a new LSB and a new carry flag. So as you can see in shifting operation, like in SHL or SAL instruction, what was happening? All the bits was getting shifted towards the left, and MSB was going into the carry flag, and LSB was getting stored with 0. So what is the difference here? In rotate operation, obviously all the bits will get shifted to left bit by bit, and the MSB will go into the carry flag as well as into the LSB. So ROL instruction, what it does, it rotates the content of the destination bit by bit towards the left. And if the number of rotations we need is 1, so we can directly mention 1 in place of count. And if the number of shifts, or if the number of rotations we need is more than 1, so we need to store that count in the CL register and mention CL register in place of count, like ROL, BL, CL. So BL is the destination and CL is referring to the count, which or CL register will store the count that is required. Next instruction is ROR instruction. ROR instruction, what does this instruction do? ROR instruction, it will rotate whatever is the RO, like the format is ROR destination count. Okay, now what this instruction will do, it will rotate the content of this destination towards the right, and the LSB will get stored in the carry flag, as well as it will go into the MSB also. So the instruction rotates all bits in a specified byte or word to the right some number of bit positions. LSB is placed as new MSB and a new carry flag. The destination can be a byte or a word. Obviously, it can be a byte or a word. It can be in a register or a memory location. The number of shifts are indicated by count. If the number of shifts required is 1, we can directly place 1 in the count position, as the example of this is ROR CX1. And if the number of shifts or if the number of rotation is more than 1, so we need to store that count in the CL and mention that CL in the count position for the ROR instruction. Next instruction is RCL instruction. What this instruction will do, the format for writing this instruction is RCL destination count. So it is rotate left throw carry. What this instruction will do, it will rotate the content of the destination towards left bit by bit, and the MSB will get stored in the carry flag, and the carry flag's content will get stored in the LSB. So again, if the count is 1, if the number of rotation we need is 1, so we can directly mention 1 here. For example, RCL CX1. So what this instruction will do, it will rotate the content of CX bit by bit towards left. Only one time shifting will, or one time rotation will occur. But if number of rotations we need is more than 1, then we need to store that count in the CL register and mention CL register in place of the count for the RCL instruction. So what RCL instruction does, it rotates the count, it shifts the content of the destination bit by bit towards left, and the MSB will get stored in the carry flag, and the carry flag's content will get stored in the LSB. Now next instruction is RCR instruction. So the format for writing this instruction is RCR destination count. It is rotate right through carry. And how does this instruction will work? Again, this instruction works like it rotates the content of the destination bit by bit towards right, and the LSB will get stored in the carry flag. This LSB will get stored in the carry flag, and the carry flag's content will get stored in the MSB. And for count, the same rule will apply. If the count is 1, we can directly write 1, and if the count is more than 1, we need to store that number in the CL register and mention the CL register in place of the count. So obviously, as I have told you that RCR, the format for writing is RCR destination count. Destination can be the memory location, or it can be a register. And count is I have already told you, if it is 1, we can directly write 1. If it is more than 1, so we have to write CL and load the CL with that number.